Hello dear learner, I am Arul Ranjan from XXIV and I'm going to give you a lecture upon graph in kinematics. So I have already discussed in the previous lecture about how to draw the parabolic graph or for quadratic equation, and I have also discussed the how to draw the linear graph for the situation in kinematics. Now in this lecture I am going to discuss about what is the meaning of slope and how it connects in mathematics. It also in this lecture I also dealt about how slope is connected to angle as well as trigonometry. So stay with me and learn a graphical approach. In this lecture I am going to discuss about the slope. Slope is very important for understanding the motion by using graph. So I am here discussing about the slope. So what is the meaning by slope? Let us look at the example that if you ride on a mountain in this way, that you say that this is the positive manner, and if you if you come down the hill, then we say that this is a negative kind of slope. So here if you go up, then we say that it is a positive slope because you ride up, you go up towards the zenith of the mountain, and if you go down towards the ground, then we say that we are just just taking negative slope of that mountain. So going up is like a positive slope and going down is like a negative slope. What do you mean by slope? Slope is just like the how steeper something is. How steeper means like this. Means if you take x-axis as this line, then this is a steeper. So if you have to ride up along the marker, then we say that this has a positive slope. But if I take this, if you can slip over it down the ground, so you can say that this has negative slope. Have you got my point? So how steeper the marker is on the ground is known as its slope. So what happened when I put the marker perpendicularly to the ground level? So you have to you have to difficulty to ride up or ride down or coming down. So this kind of slope is impossible for in the real situation. So that's why it is called as infinity slope, means steeper. It is highest steeper condition as far as possible. So it is nearly impossible to ride. That's why in mathematics we can say that it has infinite slope. So you have understood what is the general meaning of slope, and now I am going to give you the mathematical meaning of this slope. So is the slope connected to angles? Yes, obviously it is connected to angles. Here you can see that if I take this marker and making this marker making the x-axis making acute angle with the along the ground level, so it has positive slope. If I take this, then we say that if the angle is obtuse more than 90 degree, then we say that it has negative slope. Have you got my point? So if angle is positive, then acute, then we say that slope is positive, and we also say that we are going up. And if the angle is obtuse, then we say that we are going down and it has negative slope. Have you got my point? So angle is connected in some way to the slope. Now if I take the marker in perpendicular direction, or it is completely at right angle to the ground level, then in this case we can say slope is undefined. It is the highest slope ever can be achieved. So we say that it is undefined. So for 90 degree slope is undefined. In the same way, if you're going up, it is plus infinity plus undefined value, or if we go down, then we say that it has minus, but it is undefined in this case also. Now another method is the slope connected to trigonometry? If it is connected to angle, it may appear that it must be connected to trigonometry also. So we have in trigonometry, you have already learned about it, that there are 6 trigonometric ratio, that is sine theta, cos theta, tan theta, cot theta, cosec and sec theta. So what kind of or which trigonometric ratio may be connected to understand the slope or to slope. So here I am giving you some glimpses about the value of this 3 trigonometric ratio, and other 3 are reciprocal of these 3. So if you take sine 0 is the 0, sine 30 is 1, and sine 91, sine 30 is half and sine 91, and in the similar way cos 0 degree is 1 and cos 30 root 3 by 2, cos 90 is 0, and tan 0 degree is 0, tan 30 degree is 1 by root 3, and tan 90 is infinity. So you have already learned that the slope at 90 degree is undefined. So in this case, which trigonometry ratio seems to be our connected to slope? Yes, of course, you have thought about it, that it is nothing but tan theta. Have you got my point? So in the tan theta, if you take theta as 0, then tan 0 is 0, that means no slope. If there is no triangle or there is no slope, means there is a flat surface, means it has no slope at all with respect to ground. That means its angle is 0, that means its tan 0 is 0, that means it has no slope. Now for positive slope, if I take theta is acute angle, then it has positive slope, and also you can say that tan theta has positive value. Let us say that we say that this angle is 30 degree, that means tan 30 is 1 by root 3. If this angle is 60 degree, then we say that tan 60 is root 3. So we can say that the value is positive in the case up to 90. So we can say that theta is acute. If theta is acute, tan theta is positive, and hence the slope is positive. Have you got my point? So in this case we are riding up, so the value of y must increases. So for the negative case, if I take this, then this is obtuse angle. So you will learn that in this case here P is also positive and B is also positive, but here if you draw the right angle triangle, this means P is positive but B is negative. It means that if you take obtuse angle, that means it means B is negative, P is positive, that means tan theta must be P by B, it means tan theta must be negative. So for obtuse angle, tan theta must be negative, and we know that if there is obtuse angle, we are riding down, that means we are coming down to the ground, that means it has negative slope. So tan theta is the T ratio which confirms all the cases which are related to a slope. So here for undefined slope, means if theta is 90, we know that tan 90 is infinity, that means there is no defined slope, we can say in this case. So you have learned that tan theta is the only trigonometry ratio which are accurately give the idea about slope. So I am giving you some examples so that you can be familiar with the slope. So I am taking here I have taken the graph of y is equal to 5. So I have drawn y is equal to 5 like this, because here there is no mention of x. So you can take any value of x, but y must be 5. So if I take here, if I take x is equal to 1, y must be 5. if I take x equal to 2, y also 5. If I take y equal to 3, y also 5. So if I take x equal to minus 1, y also 5. So in this way, we can join all the points. So you got the graph of the y equal to 5. So if there is there is only y is equal to 5, there is no mention of x, it means the graph must be parallel to the x-axis. If there is parallel lines, then the angle between the parallel lines, you know about it, that angle between parallel lines is 0 degree. That means tan 0 is 0. That means slope is 0. That means no slope in this case, because it is the parallel to the ground or parallel to the x-axis. That means it has no slope. Have you got my point? So now I am giving you a problem to grasp the idea. If a body moves with uniform speed of 20 meters per second for 20 seconds, how can you draw b versus time? So you have to draw it. Now I have taken the another case in the graph. I have taken s versus t, and the graph is like this. So if I want to find the slope at 1 second, how can you find? So for evaluate the slope at particular instant of time, we must draw the right angle triangle. So first I have drawn the right angle triangle. So I take the line parallel to y-axis which cuts at B, and now from A I have drawn a line which is parallel to x-axis which cuts at E. So this is the right angle triangle ABE. So you can say that in ABE the angle at AE is 90 degree. Have you got my point? So you know that the slope at t equal to 1 second must be p by tan theta is equal to p by b. Here p, you can give the p is BE, and b is AE. So it is b by BE by AE. Both are positive. BE also along positive y-axis, and AE also along positive x-axis. That's why B is AE, and B, how can you calculate B? B you can calculate by this minus this is equal to this. That means 4 minus 2 is equal to BE, and AE is nothing but 1 second. That means 4 minus 2 meter by 1 second, it gives 2 by 1, and it gives you 2 meter per second. What we have seen here, the slope of ST graph give the velocity, because here unit of this slope is meter per second. It must be velocity or speed, but here I have taken displacement versus time. That's why it is velocity. Have you got my point? Have you got my point or not? Now in the same way, how can you find slope at t equal to 2 second? So I have drawn in the similar way, t equal to 2 second, the right angle is AFC. Have you seen here? AFC I have drawn at t equal to 2 second. So it is a right angle triangle AFC. So here P is FC and B is AF. Both are positive, and we can find the value of CF is like this minus this, and AF is like this. So we can take tan theta is P by B, CF by AF. 6 minus 2, 6 minus 2 is 4 meter, and it is 2 second. So 4 by 2 meter per second, this is 2 meter per second. So similarly, you can try it out for t equal to 4 second. You have to try it out yourself. So if you find the slope of any particular instant of time in this graph, you must find that the value in each case is same. That means 2 meter per second. Why this happen? Because it is a straight line, and a straight line has same direction, fixed direction, particular direction, and its angle is never changes at any time instant of time. That means here is also theta, here is also theta, here is also theta, here is also theta, here is also theta. Means angle never changes. If angle never changes, then tan theta also never changes, and if tan theta never changes, then slope also not change. If slope is not changed, how can you say that velocity is changed? Velocity does not change. That means in every case for a straight line graph, slope is fixed. Slope is same everywhere. So what we observed in this kind of problem, we have observed that slope of s versus t means displacement versus time graph is velocity, and we also observed that for a straight line graph, slope is same everywhere. I have already told you, and the slope can be determined by drawing right angle triangle at the time of instant. I have given you the idea how we draw this kind of how we draw the right angle triangle for finding slope of the graph at that instant. Similarly, you can observe by yourself that slope of distance versus speed, distance versus time is a speed, and slope of velocity versus time is acceleration, and the slope of speed versus time is rate of change in speed. And you also observe that if the slope is more, that means angle is more, and if angle is more, the graph is more steeper, and if graph is more steeper, then the value of y must be higher, or the value of slope must be higher. Here I give you example. I have drawn the two situations on the same graph, ST graph. Here first situation is like this, and second situation is like this, in which situation you can say the velocity is maximum more. In A or B, you can easily say that here its slope is higher than this. That's why the slope of ST graph gives velocity. It means it has higher velocity than this. Have you got my point? Have you got my point? Okay, now in the similar way, we can say that if you encounter the curve graph, you should draw a tangent at the instant for slope. Actually, we are taking tan theta for slope. Tan theta means tangent of theta. We actually draw the tangent. But for a straight line, if you draw the tangent, this straight line itself a tangent. If you draw the tangent here, this straight line itself a tangent. If you draw the tangent here, this straight line is itself a tangent. So for a straight line, this line also acts as tangent. So no need to draw a tangent in a straight line graph. But for the curve graph, you need to draw tangent line to find the slope. You also observe that for the slope you have to draw right angle triangle. That's why you have to need a straight line that makes some angle with the x-axis, and then you can find P and B for tan theta. So if I want to find the slope at point A, so first of all I have to draw a tangent at this point. Now I must extend this line so that it can make some angle with the x-axis. Here I have make some angle, let's say theta. Now this figure, let's say this is D and this point is A. So now we have drawn the right angle triangle AED, where at A it is 90 degree. So in the similar way, we know that tan theta is AE by DE. So in this case, we have to find the slope by this method. Have you got my point? Now, if somebody asks you what will be the slope, how can you find the slope at t is equal to 4? Then I have taken t at t is equal to 4. This point is on the graph is B, so you have to draw a tangent at this point. So this is some, let's say alpha. So we have drawn a right angle triangle. Let's say this is G, N. So this is B and G is our right angle triangle. P is here and B is this. Have you got my point? Here you say that angle is different at every point of instant. That means slope is also changes when we change when time passes. Have you got my point? In this case, for the curved path, slope never constant. So if you take ST graph, then the velocity is not constant. Velocity changes as time changes. So it is not a uniform motion. It must be non-uniform motion.